I want you guys to skip number 13. And on number 14, you need to use the formula final velocity minus starting velocity. The I stands for initial, meaning start. You're going to divide that by the time, okay? So if a train is traveling at a speed of 30 meters per second, 2 minutes later, it's traveling at a speed of 70 meters per second. So its starting velocity, or initial velocity, is 30, and the final is 70. So we would take 70, we would subtract 30 from it, and divide that by 120 seconds. So we get 40, and we know that 4/12 is also 1/3, and you should have memorized by now that 1/3 in decimal format is 0.3 repeating meters per second squared. Number 15, there are 3 ways in which an object can accelerate. What are they? First, it can increase speed, so it can go faster, so the number can get bigger. Secondly, it can decrease speed. That means the number will get smaller and it will slow down. We call that also decelerating. And it can change direction. And you might think, well, how could changing direction change the acceleration? Well, I want you to think about if you're riding your bike or you're skateboarding and you turn, that typically slows you down if you're on a flat surface. So you have to add more gas, you have to pedal more, you have to use more energy to make that turn because it does slow you down. But let's say you change direction and you go downhill, then you're going to accelerate, right? So those are the 3 ways that you can accelerate or change speed. So the definition for acceleration is to change speed, okay? In your parents' car, the gas pedal is called the accelerator. Where is the greatest amount of kinetic energy in any system? Well, let's use the classic roller coaster example. The very top of the roller coaster is where it all starts, right? Right here at the bottom, you're going the very fastest. So we know that kinetic energy is moving energy. So you're moving the fastest. That is at the lowest point. The greatest amount of potential energy, let's use that same example, but now let's think at the top. What's happening? Well, you're not moving there yet, but you sure have potential to move. That's at the highest point. The same would apply to a bookshelf. If you're looking at a bookshelf, the highest shelf on that book is going to have the greatest potential. The highest shelf on that bookshelf, will have the greatest potential. So the higher it is, the more potential it has to move or to use energy. So potential is stored energy, whereas kinetic is moving energy. An object sitting on a table has potential energy, meaning it has the potential to do something. What happens to this potential energy as it falls off the table? Well, it's transformed into kinetic energy. So the kinetic energy goes up and the potential energy goes down. Is stored energy, that's a key word, potential or kinetic? Potential. Think about a battery, okay? That has energy in it, you're just not using it yet, right? All right, graphs, your very favorite. And you guys are graph wizards. Every one of you are. I've seen it. Okay. The very first thing you want to do when you see a graph is you want to ignore the questions. So we are going to cover up the questions. And we're going to look at this graph and we're going to look at what it is looking at. We're looking at time and velocity. Remember I told you velocity is almost the same as speed. It just got direction with it. So the numbers are identical. So you could say that this is a speed time graph and it would give you the same results. This is not a distance time graph. So if we're looking at speed over time, so if we're looking at meters per second over a period of seconds, or meters per second squared, we're looking at a graph that's talking about acceleration. If I said this was distance divided by time, everybody would say, well, this is a graph that looks at speed or the direction that something is going. So you already know that here, speeding up, here, it's not changing its speed, but is it moving? Absolutely. It's moving at this speed. It's still moving at this speed. It's still moving at this speed here. It's still moving at this speed here. It's still moving at this speed here. And then it changes in acceleration. Maybe this person was driving and then it sees something that scared it and so it sped off. Okay. Or maybe it was on cruise control here and then it put the gas on here. Okay. So now let's look at the questions. What's the car doing between 0 and 20 seconds? Right here. Well, it's increasing speed. You knew that. Now, if that was distance divided by time, you would tell me it was moving at a constant rate, or that it was moving forward. What's the car's speed at 20 seconds? 40 meters per second. So at 20 seconds, right here, it's at 40 meters per second. Okay, let's just match it up. What's the car's acceleration between 20 and 48 seconds? So between here and here. That's doing this. So it didn't say what it was doing, it said what's the car's acceleration, so it's wanting a number. That does not mean it's not moving. It does not say 0.0 meters per second. It says 0.0 meters per second squared. That means it's not accelerating. In which segment is the car moving with the greatest speed? Well, you already know. You look at the one with the greatest angle, the steepest angle, C. And that is the conclusion for the physics test review. I hope it was helpful. Until next time, I am signing out.